right, it is now the top of the hour and we will go ahead and begin. Welcome everyone. My name is Melissa Arce and I will be the webinar moderator. Welcome to the first masterclass series webinar of OMS eLearning Academy. Today's webinar topic is strategic and profitable management of refineries' liquid assets. We've had an overwhelming response of 100 plus registrants from 20 different countries and welcome you all and hope that you will all have a very informational and interactive session today. Before we begin, I will discuss some of the house rules. This webinar will be about 40 to 45 minutes long and with a 10-minute Q&A session. You can enter your question in the chat box during the presentation, and it will be answered at the end of the presentation. The webinar will be recorded and available on the OMS eLearning Academy website. There will be 2 question polls at the end for your input. Please do give us your feedback at the end via the redirected Google form. You'll be asked to click continue to respond to a survey. Today's webinar speaker is Dr. Suresh Agrawal, the founder and CEO of Offsite Management Systems, LLC, and Academy Director of OMS eLearning Academy. He has a bachelor's degree from IIT Mumbai and a PhD in chemical engineering from IIT Chicago. He has more than 40 years of consulting and refinery automation projects for refineries worldwide and has published 30 plus papers in his areas of expertise. Offsite Management Systems, LLC was founded in 1998 in Houston, Texas. It is chartered to provide consulting and refineries automation projects executions worldwide. OMS eLearning Academy was founded in 2018 to provide continuing education to professionals working in the downstream refinery industry and related businesses via the e-learning platform. The Academy has 200 plus courses that can be taken online anytime, anywhere, and on any device. With this, let me request our speaker, Dr. Agrawal, to start the webinar. I will be back at the end of the presentation to go over the Q&A. Thank you so much and enjoy your session.
Thank you, Melissa. Greetings to everybody. I'm Dr. Suresh Agrawal, speaking from Houston, Texas. I hope you all have a good weather. Here is a little bit hot, but it's getting better. So today's webinar, we talk about the liquid assets and refinery and how to make it profitable. So our agenda will be, we'll talk about overview of refinery products, just to keep everything in perspective. We'll talk about attributes of a tank farm and signal tank. We'll discuss refinery economics. And then we'll talk about 6 steps to sustain refinery profitability. And what are the tangible benefits from these 6 steps? And then we'll have question answers and 2 questions poll and survey. We all know that if we take a 1 barrel of crude, it creates about 5,000 to 6,000 products by refinery. And those products have different gas, liquid, and solid. But out of those, about 80 to 85% are liquids, which are kerosene, gasoline, diesel, jet fuel, and other things. And gasoline is about 40 to 50% of the crude oil. So refinery does not sell the products which are made in process units. The products are made only in offsite operations, fuels, blendings, and other operations. So it affects your bottom line, refinery bottom line, and we'll discuss how we can improve or sustain the profitability of a refinery. So if you take different types of crude, it generates different proportions of liquid, gaseous, and solid products. Light crude oil will produce more of a gaseous and the liquid, and the list goes on. So the heavy one produces more of the solid ones. So this gives you an idea of different types of crude. The problem is these crudes decades ago were available from a single source, but nowadays the quality of crude oils are changing. So refinery have no choice but to blend something called a crude blending, where they can meet the specs of the crude processing unit. We are not going to talk about crude blending in this webinar. There is a separate webinar for this, but I just wanted to give you a perspective of what comes out of a crude oil and from what type of crude oil. So since the focus of this webinar is the profitability of oil refinery, let's look at what is the net profit of refining industry nowadays in difficult times due to various reasons. The gross margin over the years is about 7 to 8% refinery, little higher or lower, but the net margin for 2022 is 0.78%, which is still above the other industry average. So for illustration purpose, I took a refinery capacity and took these factors and see what is the profitability of or net profit of this refining industry. So it varies from 50 barrels per day to 600 barrels per day, and maximum net profit is about $140 million per year. And this is the calculation shown at the bottom. So just want you to keep the perspective in order to make sure that we understand where we're heading in this webinar. So let's look at the role of a single tank. We all know that tanks is used to store the products and the components, and it's moved between receipt and feedstock to process units and to the customers. Just a simple role of a tank. Now, if we take those tanks and create a tank farm, it has a different stages of storage. So we start with the terminals, we receive the products, crude oil and some other feedstocks by tanker, pipelines, trucks, and rail wagons. And the same means are used at the end to ship to the customer. In between, those products are stored in crude oil tanks, feedstock tanks, and they're processed to the process unit. From there it goes to the blending stocks, and what is not processed correctly, it goes to the slop, and which is reprocessed again. Goes to the blender and blended products and some intermediate product, and they're shipped out to the customers, end user customers. So the products and feedstocks move in the tank farm from one terminal to another terminal, and those terminals can be different kinds. So let's look at the typical distribution of tanks and their capacities. Now I use this 240,000 barrels per day refinery, and you can see the maximum storage is for crude oil, fuel oil, and gasoline, and others are small number of tanks. Truck terminals also 24. So the total capacity for this refinery is 13,000 barrels per day, not per day, but the total capacity in terms of kilo barrels. And if you look at the bottom chart, number of tanks versus the capacity, 50 to 100 are the highest number of tanks with the capacity. So if you just make a rough calculation that how much money is stored in these tanks, it's about $1 billion worth liquid assets at any point in this tank form. Now this is a 240,000 barrels per day refinery, but if it goes to higher, the value of the liquid assets in refinery at any point in time is many billions of dollars. So that's the what is the stake in refinery profitability. So we're going to talk about 6 steps how to manage and sustain refinery profitability. The number 1 is you have to measure the assets accurately. Then you have to digitize your data, and you cannot miss the opportunity. If you miss the opportunity, you lose money. You have to balance the books, what goes in, out, what goes in, what goes out, and the losses. You have to balance it to make sure that you can minimize those losses. The step number 5 is minimize losses, and number 6, training is very important for the staff. And McKinsey just published a paper where they're saying training is a number 3 important step in a refinery profitability. So we'll talk about all the 6 steps. So let's take the step number one. We have to measure accurately. What are we measuring? We are measuring three things of a tank: the inventory, quality, and fugitive emission. Now, inventory is the basic properties of a tank. It means you have to know how much liquid is stored at any point, real-time calculation, and we have to do the temperature compensation because temperature varies from country to country, region to region. And when you're doing a custody transfer, they all have to be brought down to the same temperature basis. And then you have to optimize the utilization of tank storage capacity. The quality is the second factor of a tank because if you have to sell products to the customer or you have to receive products from the vendor, you have to know qualities. Now, typically it's done by manual sampling and lab analysis, or you can have an online analyzers, and there are other techniques like real-time model-based prediction. We'll talk about a little bit on that one. The fugitive emission is that when the tank is loading or unloading, the vapors at the top of the tank goes into the atmosphere, and those have to be accounted, calculated, reported to the authorities. This is a very manual calculation. It's not automated at this present, or some refineries have not done automation of the fugitive emission calculation. But we'll talk about a little bit on that one. So how do we manage a single tank versus a tank farm? Single tank, if we know all the parameters of a single tank and we have a systems automated or in place, then we can manage the tank farm. The tank farm usually basically used for transferring product from one tank to another, from process units to the tanks and custody transfer. And they can run in parallel operations like a single tank transfer, or they can run multi-tank transfers like a blending. So it's important that we start with the basics of a single tank measurement and we manage it properly so the whole tank farm management can be done effectively. So in step 2, we have to transfer this data that we're getting from single tank or from tank farm, and this data is not only for tank inventory. We have to controls system as well, pumps, motor operator valves, mixers, 200,000, 200,000 plus manual valves, and they vary based on the capacity of the refinery. And then also how many paths are possible from one tank to another. We can have the dynamic path or fixed path, and the contamination and safe operation is also the consideration for the tank farm operation. So if you take a quality of the tank and you have to measure it, there was one aspect that I worked on, and I was asked the question that how do we know what is the load of a lab analysis or lab operations in a refinery? I mean, there is no way of calculating. So we come up with a scheme where we can take the lab schedule, divide 3 parameters, which is the number of sources, number of quality, and number of samples. And we make it a composite lumped parameter. And then we look at the parameter for each offsite operation and onsite operation. And surprisingly, what we find, the offsite operation has lot of frequency of high-end sampling taking, and which is normal because you have to take the sample from the tank. On-site operations, you don't take that sample that frequently. So this approach tells what is the load of lab in a refinery, and it's not only refinery, for any chemical plant. I have another webinar to discuss this in very detail and what can we do to reduce the cost of a lab analysis in refinery. But here I just wanted to see or say that what is the load distribution of a lab analysis. So we have a challenge in terms of lab analysis. First of all, it's a manual. You have to take the sample, analyze in the lab, and input manually on the database, and it becomes available. So it's about 6 to 8 hours of a delay by the time you take a sample and by the time the system or application can use it. That causes a delay in planning. We have also used NIR, NMR analyzers, online analyzers, which analyzes the qualities of the tank or the blending systems and other places. but they are only available only when you start the process. When you're blending, then only those tanks, those values are available. But even then, when planner is planning a blending, he has to depend upon lab analysis for those component. That causing delays. So what's our recommended solution? We have to implement a system, something we can track the quality of the tank at real time. And it's available to the upstream and downstreams at all the time, and planner does not have to wait for the lab analysis. Now, there is another webinar that I will be talking about this online tank tracking system in next month or after that. So the tank farm activities are very diversified and very complex. They start with the modeling of movements and blending, planning, optimization, scheduling, execution, reconciliation. So it seems that tank farm is just a bunch of cluster of tanks. Actually, it's very complex, and if you mismanage the tank farms and going back to the single tank, that's where you start losing money and profitability is affected for a refinery. So if you look at tank farm operation activity metrics, custody transfer has planning, scheduling, measurement, monitoring, control, reconciliation. The list goes all the way down. The all movement has less activities than others. And last one, the hardware management has scheduling and the reconciliation. We'll touch something on the hardware management and some issues there. How does it affect the profitability of a refinery? So the tank farm has three systems which are integrated for a refinery. And I have worked on all the three systems, and some refineries don't have any. And you will be surprised, I don't want to give the name of the corporation, where they don't have oil movement, they don't have a material balance system. So the only thing they require, they do have a tank inventory system. But when they want to move something from one tank to another, they do it manually. And it is as recent as a couple of years ago in US. So the realization is coming into picture that a refinery, to sustain its profitability, you have to have a three systems integrated together. Then only you can take the advantage of oil movement and also the material balance, which is reconciliation of hydrocarbons. So this is coming from the information for refinery. We have business challenges like spillages from overflow of tanks, fugitive emission, product degrade, contamination, demurrage charges, quality giveaway, loss of opportunity, accounting errors, oil loss, fence line balancing. And these can be done effectively if implemented correctly and by information management system, which comes the quality, process, standards, availability, and governance. And we'll touch something on in the next slides. So what did we take away from the step one? Actually, it's a little bit out of sight. We measure tank inventory, measure tank qualities, and estimate fugitive emissions. Challenges, some refineries don't even install automatic tank gauging system, and they are still doing manual, and this is fact. I was involved in a couple of refineries there. And even if they have tank gauging system, they don't have a density measurement. The density measurement is important for the custody transfer because it's done based on the mass, not on the volume. Labs are overloaded to analyze tank quality every time, and fugitive emissions are manually estimated. So how do we resolve it? First of all, fully automated tank gauging system is mandatory. Supplement the lab analysis with model-based tank quality tracking system, and estimate fugitive emission from tank movement during loading operation. Step 2 is the digitizing your data. Now we have collected the data from the tanks and tank farm. We have to digitize them. The data is coming from different processes, from fuel blending, data reconciliation, tank farm, hydrocarbon management, and this all data coming in a different system executed by different vendors, and they have their own proprietary database. So all this data have to be digitized and conciled in a simple database system, because process governs data, And when the data goes through the database, it controls the process. So this has to be collaboration, two-way collaboration between the process and data. And this is sometimes called digital transformation in a simple term. Now, how does this affect our process? If you look at the extent of movement execution, which is transferring material from one tank to another, is typically 80 to 100 transfer taking place every day in a typical refinery. And tank to tank transfer constitute about 40 to 50% of all transfer tanks. So those are the major activities. Unit to tank transfers, which is from process unit, they are sending the material to tank, is about 30 to 35%. So these two activities are the major activity in a refinery in terms of a movement. And these activities have their own issues, that how accurately they are measured. And we'll discuss a little bit on that one. So if you look at the number of transfers, inter-tank transfer per year, that goes anywhere with 3,000 per year. And this is a small refinery, about 300,000 barrels per day. But if it goes to the higher capacity refinery, the number will increase. So it's a lot of movement from tank to tank and process to unit to tanks in refineries. I worked on 6 to 7 refineries for a single corporation in US, and we installed oil movement for them, and then we monitor their movements per day. Now, if you look at this, the smaller refineries, which is 68 barrels per day, have a less number of movements, and it goes to higher number of movements for 600 refineries per day, 600,000 barrels capacity of the refinery. So what we conclude, that number of movements increases as the crude capacity increases, because that increases the number of tanks in the refinery. A small refinery has less number of tanks compared to large capacity refineries. So this is a KPI, that how is oil movement is helping the refinery to maintain and sustain the profitability. And after they implemented the oil movement system, we could monitor the movements and KPI for them. So economics, I want to touch upon economics of oil movement control system, because blending and oil movements are two major components of a profitability. Now, if you don't have an oil movement, it causes your plant profitability, operating problems, product losses, operating costs, and you lose about $5 to $8.5 million. I did a master study for a refinery in Europe. We looked at all the factors, and we found that yes, it is $5 to $8 million. The problem was that implemented fuel blending systems years ago. At the same time, they did not implement oil movement. So what happens is that if you don't implement oil movement and fuel blending at the same time, the return on investment from oil movement is about 3 to 4 years compared to 18 to 24 months for fuel blending. So it's highly recommended that a refinery thinking to implement oil blending and fuel blending systems together, they have to do it together to make maximum return on investment. Blending system is very complex. It has about 9 to 10 modules, and each module is integrated. We start with the laboratory, with the Tankfarm, automatic tank gauging system, DCS, additive control systems, optimizer, and blend control. Now, I want to make a point here. You see the blender skid, which is the blend header. Typically, it's conceived that the blend header is nothing but a piece of pipe, which is not true. Actually, the design of the blend header is very complex. And I have devoted one full webinar on the design of a blend header. How should the blend header be designed to make fuel blending more efficient? When you get a chance, you join us, register for that webinar, and you will learn all about blending header design. So from step 2, what are our takeaways? All the process data must be available across all systems and applications real time. Whether it's a planning at the corporate level, whether it's planning at the refinery level, it's a control, it's oil movement, all the data have to be residing on single platform to make use of real-time information exchange. The problem is that the data is coming from different sources, from a tank engine system vendor, from a fuel blender, from an oil movement system. And I work with 5 or 10 vendors supplying these systems in their own database. And it was a nightmare to combine the information from different database and bring it to central database to make it available across the systems and application in a refinery. So digital transformation is the future, and it's a must for seamless operation, planning, and process control. Now we go to the next step. Don't miss an opportunity. Now this is a very complex subject, but I'll just touch upon few. The refinery have to be able to switch between the diesel and gasoline based on the market shift. As we know that the demand switches from gasoline to diesel, and especially in Asia and other than non-US countries because of the automobile requirement. So McKinsey did a study, and they said, well, the refinery which are able to switch quickly between 2 to 3 months between the diesel and gasoline based on the market, they get additional benefit of $10 million. So they should be able to optimize the process unit to produce more diesel as market shifts. Minimize reblends for faster delivery to customers. If your specs are not met because of various reason, quality control and not proper blending system, you have to reblend it. But you're reblending, you're losing time because customer is waiting and you're not able to deliver to them. I have seen delays at least 2-3 days, if not more, when there is an order from the customer and refinery not able to provide them because they have to reblend it. If an inventory is sitting in your tanks, that's a stagnant inventory. Like if you have money in a checking account and it's sitting there, you're losing interest, you're losing other benefits that you could get moving money out of the money. For refinery, inventory in the tanks is the money, and the more they keep it there for days, they lose the revenues. Sometimes you don't have enough tankage allocated to the right processes, and because of that you have to move a lot of products here and there. Give you an example in the next slide that you have to allocate them effectively. On the first diagram, I have worked with a refinery where they had a less number of tanks for blend components. So they had 14 components and they had only 10 tanks. So what happened when they were blending, they have to struggle to switch the tanks based on what is needed for the blending. And that took time, and they could not deliver to the product, to this thing, the customer. For a blending, if they don't have 2 tanks per component, one tank is blending, other tank is waiting from the process units. They don't have a spare tank. That causes the delay. And that's sometimes a serious delay because the blending is not completed. Third one is the qualities are not available in time. Lab has to take a sample and they have to analyze it, I said before. The fourth one is the truck terminal. In typical days for the refinery, there are about 200 to 300 trucks waiting in line to get their products. And if it's not done automated properly, then it's a loss of delivery to the customers. So these are the few examples that the reason for delays. So what are the takeaways from this step 3? Refinery should be able to shift production as market shift, and they should be able to repurpose the process unit per market. Minimize delays at all stages of receipt and delivery, and all operation may not be automated. Staff is not trained enough to act fast, and sometimes unforeseen circumstances require timely mitigation. So resolution is that refinery have to do a master study to explore areas of weaknesses and lack of automation of critical systems and implement the recommendation by vendor or consultants. Step 4, balance your books. Now, this is a major hurdle for refineries. Believe it or not, it's a very complex, and refineries are still struggling in terms of what system to implement, what process to implement the flow. And we talk about starting with fence line, which is at the terminals in and out. So supplies are coming from third-party chemicals, manufacturing, and then goes to input or inventory, to tanks, scheduling. It is process, then it goes to output, and goes to customer. Now, whole process looks simple on this diagram, but in reality, it's very complex. And any process which is not done correctly or is an error, refinery loses millions of dollars every year. And we'll talk a little bit on that one. So if we take as mass balance at all, which is reconciliation of hydrocarbon, it has a different term. It's anywhere loss is 14 to 24 million dollar, initial top down, and it has a different categories. Where are you losing the money? You are losing the money in plan versus actual. Now, I work with a refinery where the CFO told me that they lose sometime $100,000 on a single shipment. It means customer fights with the refinery. Refinery says we send you this much material. Customer says I did not make this much material, and that battle goes on, and the loss was of $100,000 for a single shipment. And it's because there was no reconciliation, what was shipped out and what was received on the refinery side. So there's a lot of money involved in this thing. And refinery started realizing that mass balancing or reconciliation is a major impact on their profitability. If we look at the typical refinery loss and gain distribution for 3 years, I took the data for 3 years. Typical range, you can see it goes from 0.2 to 1%, but the industry average is between 0.4 to 0.6%. Now, there is a myth that the oil loss is a positive number, and it means that you lost the product. But if it's a negative, what it means that you gain the mass, and which violates the law of physics. And you will see some of the refineries are struggling with that. The data shows that you have gained mass rather than losing mass. So how much money we talking about? So we are talking about, say, if I take 0.5% oil loss, and it says by installing a automated system and all process or workflow, we can reduce to 0.1%, 10% of that one, which is 10% of 0.5 is 0.5%. And I took a different capacity refineries. This is for the same corporation, and you can see some of the names. They are losing $1 million to $8 million per year for each of the 10 refineries. So if you have a 10 refineries in a corporation, you're losing about $80 million per year by not able to reduce the oil loss, even 0.05%, and which is feasible. And we have seen in our practice. The problem with the data reconciliation or hydrocarbon reconciliation is the integration, and it's a lot of processes, including a lot of systems, SAP, PI system, data reconciliation, which is from the oil accounting, and handling at the terminals, which can be manual or automated. So I worked on a project for 3 years, integrating all this system for 10 refineries, and at the end, it was very complex, and something was left out. So integration of system and platform is a big challenge for refineries. So what are we taking away from step 4? The reconciliation of hydrocarbons and calibration of meters is very important. Now, it's reported in the industry that if the refinery does not calibrate its meters properly, they're losing about $10 to $15 million per year. And not only that, it has impact on the process control, because if you're controlling the unit and your meters are not calibrated properly, you're controlling to the wrong value. So flow meters have to be calibrated. So challenges they have, that refineries don't calibrate the meters frequently. Reconciliation software is not installed, all movement is manual, and they're doing monthly estimation of hydrocarbon balance. Now the last point on challenges, one of the refineries that I work with, they took the challenge, okay, we'll do daily balances of hydrocarbon balances. Okay, They implemented the system. They mobilized about 100 people in the different departments, and they did the daily balance. Well, the outcome was good, but the work was so much that they gave up after 3 months. So they don't do daily balance anymore. So the point is you have to make a balance, whether you do a daily balance or a monthly balance. If you do a monthly balance, it can work, but you have to make sure that your data is correct and the process flow is correct. And for that, you have to maintain the flow meters, install reconciliation software, and there are many systems in the market which are proven for reconciliation as well as the oil movement control system. And you have to implement end-to-end workflow. In my experience, even if you install all these automated systems properly and commission them, but if your system does not have end-to-end workflow properly installed, you lose the benefit of that. So people have to be involved, they have to be trained. So step 5, we have to minimize your losses. Now, as I said before, the refinery is divided into 2 parts. Is the on-site and off-site. An on-site operation is only the process unit, but off-site operation, which makes maximum money for the refinery, consists of moving products and shipments or feedstock from a receipt to shipment. And it goes through the order movements in and out, tank inventory, crude blending, in-plant movements, and product blending. And every one step of them has a potential of losing money because of various reasons. So we start with fence line balancing, which is at the terminals, the product coming in, product coming out. So this is when you're opening stock, what we have right now, the tank inventories. What are we receiving, either from the process units or from the vendors? And then at the end, what is our closing stocks, which is shipment out. And this is called a fence line balancing. And refineries have struggled to a proper fence line balancing because it's not a manual operation. It has to be automated properly, have to integrate it properly. So from this stage, it goes to, so before, when we talk about the challenges that the terminal operation or the fence line balancing has, if you are marine or if you are truck terminal or a pipeline, some of the challenges are severe, like for marine terminal, demurrage charges are severe. Opportunity loss due to product unavailability. Quantity giveaway due to faulty meters. So marine terminal has the highest degree of severity. And next one is the pipeline. Trucks and rail car is medium to small severity. So you have to pay attention to your mode of transport and receipt at the terminals. So once we do the fence line balancing, then we go to the process unit balancing and losses. So in process unit balancing, we are producing different components and we are measuring them and we are consuming them within the refinery. It's called on use. So that's called refinery loss. And then we have process loss due to slope, due to water drains, zero value products. That becomes a total loss. And then we have accountable loss, which we can measure, like chemical loss, fugitive loss, filler loss. You can measure it manually or you can measure it automatic systems. Yeah. Then there are some losses which are unaccountable losses, which are handling losses and meter uncertainty and leakage. Those are the losses which are something refinery do about it and something they cannot do about it. And in the end, the percentage of loss and gas is considered as a refinery loss. If you take a tank to tank transfer losses, you're transferring from one tank to another. The difference between the measurement at the source and the destination is your loss. And for this typical example, I've shown that there's a loss of 67.5 pounds. You know, it's a simple, but when you multiply by 100 to 200 tanks of transfer, the loss multiplies and the profitability is affected. This is a typical case 1 and case 2, where all these losses are calculated and estimated. Now, if we look at these graphs, all the bars which are above the zero line are positive loss and gain. It means the mass is lost, which is per law of physics. But all the bars below the zero line says that mass is gained, and which is wrong. But it's not wrong because of the law of physics. It's just a measurement and calculation errors. And I have seen for and refinery struggling that the number that see below the zero line should be not be there and should be corrected. So this reported correctly. And this is done in terms of reconciliation, in terms of manual calculation, estimation, and refinery is struggling with that, at least the experience that I have with the refineries. Then there is a lot of complex integration of manual and auto data entry losses. Now, if you can look at it, we have systems like LIMS, which is lab, databases, data reconciliation, tank information, oil movement, reconciliation, and SAP, which is recording the orders and dispatches. And these all have to move from each other. And these are some manual, some are automated, some are calculated, some are estimated. So the complexity of integration is what it takes. A refinery is a huge effort in terms of both resources and manpower. So what are we taking away from step 5? We have to minimize the losses due to manual data entries, minimize process losses, faster accounting of balance. And challenge is that mass balancing or reconciliation is very complex and it's a time-consuming process. It involves staff across many departments. Analysts may not understand the refinery entire workflow. Visualization is, don't be over ambitious to do a daily balance. It's a huge effort, so in my experience. Implement a robust and industry-proven reconciliation software, and there are plenty in the market. And then you have to have a seamless integration of workflow and operations. Now we come to the 6th step, the training. Now training is typically ignored in refineries for various reasons. And that's really causing some dip in the profitability of refineries. So what are the options? There are 4 options that I've listed here. The first is in-house training. It may refinery use their own experts who are experienced engineers and managers to train their juniors and newcomers and transferees. The problem is that those courses cannot be held very frequently. It requires time and availability of the experts, and they retire. Once they retire, the expertise are gone. So the newcomers comes and they have no way to go to learn skills to do their jobs. The next option is public courses. Yes, some consultant teaches public courses on very focused area, but those are very expensive. They require the time off from the staff, and the budget has to be implemented in the refinery. So that also sometimes is not implemented. Then you go to online courses, which is inexpensive. There is no travel required, online interaction, but again, it takes a time off. It means you have to sit down from the terminal and take the courses. And if you do it in your job time, then that is sometimes not recommended. The last option, which is coming up in last 2 years, especially in our pandemic travels, that e-learning courses that refinery, I mean the consultants or refinery staff find it convenient to take the e-learning courses because it does not require time off from their job. They can take it anytime, off time and on time, and it's inexpensive. It's not as expensive in other cases. If you look at the cost of this thing, e-learning courses about 25 to 30% the cost for similar public or private courses. And refineries can save millions of dollars in training every year. And advantage is that this not only one focus course, this course is available for entire spectrum of refinery operation. And this can be also combined with a hybrid option. It means you combine with the e-learning and the public courses. Now, I taught recently a one-day course on advanced blend control optimization for 40 plus engineers from refineries, 13 or 14 corporation, 13, 14 refineries, and they wanted to learn only the blend control for Phillips 66. And the audience was anywhere from 0 years of experience to 30 years of experience. And everybody had the same motive or same objective to learn what's the latest technology in the blend control. How can we make our blending profitable? And the key takeaway was refineries are losing tangible benefits of 24 to 30 million dollars per year from fuel blending. Some of the components they are not done correctly, the models are not correctly, the analyses are not there. So this is a hybrid model. You can take extended course, say for a fuel blending. I taught it for EcoPatrol for 3 days course, and then you take the whole spectrum of blend technologies, not just optimizer. Just information, we have an open house for 7 days. For academy is open for 200 courses. So it's just for information. I'll be posting this on LinkedIn. So what are the takeaways from step 6? The training is very much required for new and skilled staff for onboarding and continuing education in operation. Every other profession takes a continuing education, whether it's doctors or lawyers. Why not refinery professionals? They should be trained. There should be easy way of training them, and not wait until course is available, public or private. Resolution is explore e-learning and OMS e-learning academy, and customize your curriculum for what you need, and you can learn anytime, anywhere, on any device. Suit your schedule to learn. The last important slide is, so the 6 steps, what are the benefits? I mean, what are the tangible benefits? So I have listed here the tangible benefits and ROI. So you can see it's about $40 to $70 million per year benefits from all the 6 steps, and about 3 to 24 months of ROI if we do it all together. But if we do separately, then it can go anywhere from 6 to 12 months, or 12 to 18 months, or 18 to 24 months. So the question comes, how did I get these benefits? Now, these benefits are calculated, estimated, considered over my 40 years. And that's why you see the range and don't see the fixed number. But these are very tangible and very real. So we have 12 webinars in the 1 year. These are the list of the webinars. And if you have another topic to suggest for the webinar, please send me email and we'll accommodate your request. The next webinar, which is number 10, is talks about 4 aspects of refinery operation, which is MCORE: how to manage infrastructure, how to control manufacturing, how to optimize production, and how to reconcile hydrocarbons. The profitability and efficiency increases from management of infrastructure to reconciliation, whereas effectiveness increases from reconciliation to management. And we have used the principle of MCORE by using a divide and conquer principle, and we will discuss it in the next webinar. So this is the end of my presentation. I give the platform back to Melissa.
Thank you so very much. Please note that if you do have any questions, I do ask that you enter them into the chat box, and I will be happy to read them out to you and for them to be answered. All right. At this time, we do not have any questions. If you do have any questions, please feel free to respond and place them in the chat box. I will go ahead and launch the poll question. Please take a moment and respond to the two poll questions that have been displayed upon your screen. After you respond to the poll questions, we do ask you to remain online for our closing. And then once you disconnect, you'll be asked to click on the word continue to respond to a survey.
Melissa, there are a couple of questions. They are sent directly to me. Can you send?
I cannot see the ones. Yeah, so I cannot see the questions that have been sent directly to you.
Okay, let me give an answer here. Training using operator training simulator could play a major role in the safe operation of the refinery. What is the role of IoT device in OMS? Well, OMS is basically a offsite operations like blending and tank farms. Uh, Only simulator that we use is in the blending is that how to go from end to end for blending systems. This is different from on-site operation simulator, which they trained the operators how to control and optimize and do other thing process units. Offsite operation does not have so much need for the simulators because they are done on not real time. They are done in as they occur. Next question is, can you share what is the approximate cost of quality giveaway in sand barrels of crude processed? Typically, if you take about 20 to 24 million dollar per year benefits, and if you take convert that, it comes about 2 to 3 cents per barrel in terms of quality giveaway. And these numbers are very much reported in the industry, and they are practiced. I mean, I have seen those numbers. Sometimes it could be more, depends upon how bad the blending operation refinery are. But they are about 2 to 3 cents per barrel. Next question is, what are the prime reasons for damage losses, communication gap, technical issues? For damage losses are mostly, look at this, if you have first of all, you have to schedule your crude supply. Now, if the crude supply is not scheduled properly, or they have a problem in the shipment, the ship is sitting in the dock and you don't have a tanks ready to unload to, or from a pipeline unload to, because you are moving the crude from one tank to another for the crude blending, that causes the damage losses. This is again regards to communication gap and technical issues.
Hold on.
If you have any question, you can always email me and I'll reply to you personally. Okay.
All right, I'm going to go ahead and end the poll. We have 75% who have responded. It's a wonderful number. Thank you so much.
Okay. Melissa, what's the next step?
All right. So now that we have completed the poll questions and have responded to the questions that you sent Dr. Suresh in chat, you are able to disconnect. Unless, Dr. Suresh, do you have a quick closing?
Yes, there is a couple of questions that I want to answer. How do you rate the benchmarking on offsite tanks by benchmarking is done in two ways. One is for fuel blending, and second one is how best you are utilizing your tanks. Do you have the enough storage? Are you moving them correctly? So there's a process, and I will be holding a webinar on the benchmarking. So sign up for that one. Yes, the digital blending is successfully implemented in many places, along with the fuel blending, gasoline blending. Yes, and digital blending, I might add, I've implemented a system for a refinery in Singapore where digital blending was directly from the units, not from tank to tank, because digital blending is usually have both, either directly from the units or directly from the tanks. So send me email and I'll reply to you. There's a paper on it which I published on the digital blending. Okay. I think that's about the question I have right now.
Awesome. Well, we'd like to thank you all for joining us today on our first webinar. Again, please join us on the other webinars that have been posted in the LinkedIn. If you have any questions, again, please feel free to email any of your additional questions to the email that is posted on your screen. Before you hang up.
And please take the survey and give us your feedback. That will help us to improve our delivery and content. Thank you so much. Have a good day.
Thank you, everyone. Have a wonderful day. Please remember to click continue once you exit, and you will be directed to the survey directly. Thank you, everyone, and have a wonderful day.